record. Fun times. Okay. There are we're talking about the properties of logs. I have a little question on the side over there. Okay, it says guiding question. A little star next to it, right? And it's all about exponents, okay? We are good as human beings at figuring out 2 to the 0. What's 2 to the 0? Let's write this stuff down. Good. 2 to the 0 is equal to 1. What's 2 to the first?
2.
Good. What's 2 squared?
4.
Great. What is 2 to the third?
8.
Good. What is going on in the between there, though? How come, what's 2 to the what would give me 5?
Somewhere between 2 and 3.
Yes, somewhere in between 2 and 3. Would it be closer to the 2 or closer to the 3?
2.
It'd be closer to the 2 because 5 is closer to 4 than it is to 8, right? Okay, so this is going to be something that we're going to encounter once we get to the starred problem on number 3. We're going to learn how to do this today, okay? And that's going to help us out. So anyways, let's start with the first two. All right, the first two basic properties of logarithms. Here you go. If you have log base A of 1, what would that have to be and why? It's very simple. It would have to be 0. And how come? Because why? Because A to the what power gives you back a 1. What would that power have to be? 0. There you go. Because A to the 0 gives you back 1. So far, so good? All right, great. Let's go on to number 2. The number 2 says this. If you have log base A of A itself, what would that have to be and why? That would have to be 1. Why, Christian? Yeah, because A to the first power gives you back that A. So when you exponentiate all this stuff, right, you get A to the first power gives you back A. So that's why that is the case. So those first two are kind of just gimmies, kind of basics. Okay, the third one is when it gets kind of interesting here. So this has something to do with this property over here. If you have A to the power, the exponent of log base A of M, gives you back M. Now it looks really weird, it looks really strange, it looks like something that has nothing absolutely to do with that guiding question on the left, but let me give you an example. Okay, if I said to you 6 to the log base 6 of 8, what's the answer going to be? The answer is going to be 8. So, could you apply the example to the guiding question? Could you plug in the 2 and the 5 in the right spot? See if you can get it. Yeah, okay, so going back over here, right? Using this property, let's bring this back over here. If you have 2 to the log base 2 of 5, that will give you back 5. Now, that's not a very satisfying answer, is it? It's like, what does that even, that's not very good, right? So what we tend to do in this particular case is we look at this and we say, okay, this is the exact answer. The exact answer. But for us, for some reason, we're more satisfied with an answer that's closer to 2 than it is to 3, like Daniel was saying in the very beginning, right? So when we figure this out, this should have a decimal point of about 2 point blah, 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 right? So we know that our x value is somewhere between 2 and 3. Is that safe a parameter to say? Okay, so how do we figure out what it is, approximately, because for some reason that gives us a more satisfying answer for this one. 2.3, that's your guess? That's a pretty good guess. Let me show you how to do this. Have I introduced you to the change of base formula? Some say yes, some say no. That's awesome. Okay, let me clear that up. The change of base, that's a D. I have dyslexia. Change of base formula. I really do. You guys don't know that? You guys haven't heard that story? That one was really sad. That was a sad story. Sad state of affairs in my childhood. Thanks, Mom. Thanks, Mom. That's really bad. Sometimes he does. All right, here's the change of base story. If you have log base A of B. Oh, they're divorced. All right, no. That's another sad story. I'm just full of sad stories. All right. Here's the log. Here's the change of base formula. That's what you need to know. When you push the log button on your calculator, when you push the log button on your calculator, it has automatically geared toward a base of 10. So how do we change that base to get something that we can use? All right, here's the deal. Let me show you. Log base a of b is equal to, you could have log base 10 of b divided by log base 10 of a. You're allowed to use any base that you want because the change of base formula allows you to make this division true and figure out. Did I show you that or not? All right, so great. So let's go back over here and let's figure out what is the log base 2 of 5. We're going to use the calculator to do it. So here we go. We're going to turn our calculator on and clear all this stuff out. So if you hit log, notice that there's no base, right? It's an automatic base of 10 when you push the log button. So even though it's not there, the calculator is assuming a base of 10. So here's how you get around that. We're going to say log base 10 of 5 divided by a log base 10 of 2. All right? That's the change of base formula. When you push enter, notice we get about 2.321. If I round this to 3 decimal places, I get 2.32 what? 2. Okay, so 2.322. So this is about, when I go back over here, okay, this is about 2.332 or 22, what was it? 22. Good. So let's check to see if this is about right. Watch this. If we take 2 and we raise it to the exponent of 2.322, I would expect my answer to be approximately what? 5. Oh my gosh. There it is. Isn't that cool? We have never been able to do that before today in your entire lives. It's a good thing you showed up to class today. Okay. Let's take this one step further since this is my favorite property. Let me ask you guys this on-the-fly question. 3 to the what power is 7? Huh. Yeah, find the exact answer and then find the... Let me show you how to do it. So, to pull up our calculator to examine this, we're going to say log base 10... on. We're going to go log base 10 of 7 divided by the log base 10 of 3. Dividing. The division is the key. And we get 1.771. So if we took 3 and raised it to the power of 1.771, we should get about what back from this? And check it out. We get about, if we round to 3 at some places, do we get about 7? Yes, we do. So now you have the ability to find any exponent to any value you want. You're not just limited to those perfect powers. That's pretty cool stuff. All right, going back to our real lesson here. Number 4 is a pretty interesting property as well. It says this: if you take the log base a of a raised to the r power, so log base a of a to the r, it's kind of strange, right? Well, what's log base a of a? 1, right? So 1 times r is just r. So this is just r right here. All you get out of this thing is just r. So log base a of a to the r is just r. Okay, those are the 4 basic properties. Yeah, question? No, okay. Log base a of a to the r is just r. Yeah, like as an example, log base 2 of 2 to the 5th is 5. Okay? Cool stuff. All right, here you go. Here are the 4 main properties for expanding a logarithm. There are 4 main properties for expanding a logarithm. Number 4 is really fun. Here you go. If you have the log base a of 2 quantities that are being multiplied by each other, m times n, you're allowed to expand this over addition. What I mean by that is log base a of m plus log base a of n. So multiplication becomes addition. I know, super strange, right? Why? That's in the proof. And I would love to show you that one-on-one. It's kind of fun, but not right now. But it's pretty strange. All right, now, think about this. If multiplication is expandable over addition, there's only two operations that are left. So let's talk about log base a of m divided by n. So how do you think you expand a division problem?
Subtract.
You subtract. You guys got it. log base a of m minus log base a of n. So division is expanded through subtraction. It is super crazy. Number 3, the reciprocal property. Log base a of 1 over something becomes the negative of that. So log base a of n. So reciprocal becomes a negative. These are like super strange. Never seen anything so weird before. And number 4 has fundamentally been dubbed the plop down by third period. You can talk to third period about that. It's my favorite property of all. It goes like this. The log base a of m to the r. Now this is different than the first property, number 4, right? Let me see my backs. See how the base and the logarithm are identical to the r? Well, that's not the case here. The base and the logarithm are not identical, right? This is called the plop down property because the r gets to plop down in front of the logarithm. This is called r times log base a of m. Super crazy, huh? All right, a little bit of review. So we have the 4 basic properties. We have the 4 main properties for expanding a logarithm. What we're going to do now is 3 examples, A, B, and C, and then you guys get to do that nasty thing on your own. Doesn't it look rad? Don't worry, you'll be fine once you get there. So let's get back to it. Okay, give you a little guiding hint on the left-hand side there. Don't forget that when you take the square root of something, it is exactly the same thing as taking that base to the 1 over 2 power. In this case, it's a square root, so the 1/2 power. We're going to use that.
So is 1 over 3 the cube root?
You got it. Yes.
Or 4 is the over?
Yes. If you have the 4th root of x, it's the same thing as x to the 1/4. It amazes me every year how much that we don't actually push the right-hand side of that. We only push the left, But they mean the same thing. Okay, here you go. The first one, let's do this. Let's do log base a of x times square root of x squared plus 1. All right, there are 2 things happening here. One of them you can probably see right away. The second thing, you have to sort of use that guiding question on the left to see if you can get it. Does anybody see the first thing that's happening right away if I want to expand this logarithm? Multiplication. And how do you expand multiplication? Over addition when using a logarithm, right? So here's what you get. You have log base a of x plus log base a of the square root of x squared plus 1. All right, now I have 2 terms. I have the one on the left and the one on the right. One of them I'm done with. Which one are we done with? The one on the left. We're done with this stuff. But we still have some more to do with the right-hand stuff. Does anybody see it? And it's got something to do with this stuff over here that I'm highlighting. Yeah, Daniel.
X plus 1 to the 1/2?
Yes.
Or x squared plus
So this is log base a of x plus log base a of the quantity x squared plus 1 all to the 1/2 power. Beautiful work. Now, however, we get to use the fun property, the plop down. Anybody see it?
Yeah.
Where does the plop down occur? The 1/2 before the logarithm. But notice that it does not go in front of both of them. It only goes before the one that it's actually being plopped down onto. Yeah, there you go. So, we got log base a of x plus 1/2 times log base a of x squared plus 1, and you're done. What do you think about that? They're like mini puzzles, and you just gotta like work with them. They're like transformers, right? They're tiny, you gotta expand them, and then sometimes they're expandable, and you gotta put them back together.
So, that's the answer to A?
That's the answer to A.
Why is it better to have the 1/2 in front? Why is it bad for it to be a...
It's not necessarily bad. It's just not fully expanded upon. Yeah, and that's the skill that we're trying to develop right now is learning how to take all 4 of those properties and use them when we're supposed to use them. That's really all we're doing here. Question? Yes.
When do you use logarithms in
daily life at all. What is this talking about? So I'm with you, but we're going to do some stuff with it. Okay, let's do B. Let's get this skill down. Log base A of, let's do x squared divided by x minus 1 all to the third power. All right, what is the basic operation that you see first? Mr. Brem, what do you got for me? Subtraction. Well, that's going to be how we take care of it, right? And we have that because we have a division problem, right? So this is log base A of x squared minus log base A of x minus 1 to the third. All right, are we done? No, we have to do the what? The drop down, the plop down, right? So here we go. So we get 2 times log base A of x minus 3 times log base A of x minus 1. And that's your answer for them. What do you think, you guys? You guys, like stage 1, you don't get it. Stage 2, you can only get it if I help you. Stage 3, you get it all by yourself. Huh? I moved it. Yeah, I was down there behind there. Yeah. This is better, right? Yeah. All right, we're almost there, right? Okay, let's do one more. Do you have a question? Remember. All right, C, here we go. Big gnarly thing. Let's do this. Let's do log base A of x times x squared plus 1 all divided by x plus 4. Now, the other classes that said, do you want to distribute that x inside so that x to the third plus 1? No. And the answer is no, because we want to practice expanding. What do you want to say? Okay. We want to practice expanding this, and the skill is recognizing the fact that you have a multiplication on top and a division altogether. So here's what you're going to do. We're going to expand this by log base A of x plus log base A of x squared plus 1 minus log base A of x plus 4. Look, we did all that in one fell swoop. There you go. We've expanded that thing.
Don't we have to do something with that exponent?
No, not this exponent. Because it's like that. Yeah, that's part of the term. All right, here you go. We're going to do a U-try. U-try. Now, I've thrown 2 curveballs at you in the U-try. Did anybody see one of the 2? LN. Okay, let's get this LN thing out of the way. People still sit this in all my classes. When you see LN, let's not call it LN. Let's actually call it what it is. That says natural log. So refer to that as natural log. So that's the first thing. Now, do properties of logarithms apply to natural logarithms? Why or why not? What do you think? Yeah, because it's just a log with a base of e. So the answer is yes. So because you have a natural log up front, that does not mean anything. Same rules still apply. What's the other thing I've thrown at you? Yes. There's 2 exponents, and notice that this one plops down in front of the entire piece before you start working inside. So bring it down first, and then... All right, there it is, you guys. Take a look at it. And the final answer should have been 4/3 natural log of x minus 4 minus 2/3 natural log of x squared plus 1. Who got it right? That's sweet. That's awesome. So those you guys are stage 3ers right there. Look, that's to the end of our lesson. I want to go ahead. We're going to do this in-class assignment because this is the one that we did not get a chance to do on block day or whatever it was we had. So you should already have your book out. And I want to do number 1 and number 4 with you really quick. So go ahead, take out a piece of paper and set this assignment up. All right? And I want to do number 1 with you. So I'm gonna stop the recording.